Okay, section 4.5 is on direct variation, and it follows linear equations. And as you can see on this slide, it says direct variation, write linear equations that represent direct variation. So direct variation is a linear equation. And I think sometimes that gets lost in this lesson. You'll see here that we have y equals kx, and we say that k is the constant of variation. I like to think of k as m, as y equals mx plus b, and in direct variation, b is 0, and that's why there's nothing there. So where it says y equals k times x, it could just as well say y equals mx plus b, and b is 0. When we graph direct variation, the graph of the line is always going to go through the origin. That's why b equals 0. The slope of the line is going to be the k. And so this is a direct variation model. Of course, this is a line, almost the same slope, but since the line isn't going through the origin, since b looks like it's somewhere between 4 and 5, this is not direct variation. So here's the kind of problem that you'll have in your homework today. The variable x and y vary directly. When x equals -3 and y equals -30, write an equation that relates x and y. And after you write that equation, find the value of y when x equals 8. So you start with y equals kx. Again, if you wanted to say y equals mx plus b and b is 0, that'd be fine. We plug in -3 for x and -30 for y. And then we solve for the slope, k. And when we solve for the slope k, now we have enough information to write our equation, y equals mx plus b, or in this case, y equals k times x, and the 10 goes in as the slope. And this is our final equation. So if number 1 says write an equation that relates x and y, the equation is y equals 10x. That's direct variation. And then if they say find the value of y when x equals 8, we're going to plug in an 8 for the x, and of course y is going to be equal to 80. And that's our example on direct variation.